Yeah, go ahead.
Oh, yeah, the partition by I have like a good understanding of that. I think it's the order by when you're doing the over window function that I'm wondering how that changes the results.
Sure.
That's like the part of it that I'm kind of struggling with.
Mm-hmm. Cool. All right, so we should definitely talk about that. Other questions before we get going? Okay. All right. So this is, yeah, we can move into, oh, this is a lab. We won't do that. Yeah, this is pretty good. Okay, so let's talk about this reading. So just load in some data, save the data, and then do a select all. Okay, so let's just keep track of what we're working with here. So we have basically different stores. You can think of this as like Walmart, or yeah, this is Walmart essentially, right? And Walmart has different store numbers. Like we can see it has at least 25 here. And then for each store, like for instance, we could probably do where store number equals, I don't know if it's a string, equals like 10. I should probably do double here. Let's see if that works. Okay, so for each store, you can see that we have multiple days. All right, and on each of those days, we have different numbers of transactions that occur. So this is a very good use of window functions because, like I said, we can compare to like same store, and we can compare to kind of like same date different stores. But before we get into that, we're obviously not using window functions here. One thing to note is like the biggest comparison, the comparison we often draw is to group by, right? So with group by, let's say we group by the date, okay? And then we do like the average number of transactions. Before I run this, right, the good thing to ask yourself is just does this change the number of rows returned? Okay? So we're grouping by the date. And if so, then, well, how many rows does it return? And the answer is yes, right? It changes the number of rows returned, and it will give us one row for every date, right? We have 25 stores, but there's now only going to be one row for each date. All right, so you can see, okay, there's 1682. I guess we're tracking this over a few years. And let's also do I think we have the date. Yeah, so you can see for each date, we have the average number of transactions if we're grouping by date. If we do partition by, and I'll just do this like as average trans. Okay, so if we do partition by, then right, the difference is select date, average transactions. Let's remove the group by. And we'll do partition by. What am I doing? Over is the first word. So this is average transactions over. And now we'll do partition by the date instead of group by the date. So now, before we had like 1682 rows. In this case, let's see how many we have. We have 83,000 rows. So the point is that this is going to be the same number of rows that we started with. And you can see that we have date, store number, average transactions. And let's also do what is it called? Transactions. That, I'm sorry guys, I just switched. Okay. This is getting annoying. I'm going to delete this. It's getting too annoying. All right. So what we're doing is we're selecting the date, the store number, the number of transactions. This is transactions per date, per store. And then the average transactions, the average of what? This is the average for that date, okay? So I guess on January 1st, 2013, there was only one store that we're talking about probably. But here, you can see for each date, we have the same number of transactions, okay? So that's one thing to note is like, this is not reducing the dimensionality. In fact, it's really not changing our result at all, except for what occurs in this column, right? Like when you do a window function, it is the effect is specific to the column, just to this column. Everything else stays the same. All right, with group by, that does not occur, right? We like condense the rows into groups, and that's all we show as the resulting groups, one row per each group. So we can call this, just call this column as average transactions per date. Okay, so there were 2026. This was the average on January 2nd, 2013. Now, okay, so kind of so questions about this so far, right? This is putting it into groups in this column, right? It's really just with respect to this column. And just note that we can order this however we want. I can order this by the store number, comma, let's say we order this by store number, ascending, comma, date, let's do date ascending. I think I can do that, right? So now we have store number 1. This average is still the average per date, right? For January 13th, January 2nd, January 3rd, right? So it did 1833, this store, but the average transactions on that date was apparently 1706. And this is slightly different, right? So just note, when I do this order by, I'm affecting the order of the rows, but, and when I would do something with regard to the window function, it's just talking about, it's only affecting this column. Okay, so this is average per transactions by date. How many did we sell on a specific day? If we do, let's take out this order by for now. And now let's do this. We'll order by the store number. Now we'll order by the date, descending, or ascending is fine. And then let's just do where the store number equals 1, just to make it easy. Does this have to be, I forget what has to go, yeah, this is good. Okay, so now we just have store, this is just this one individual store. We have, this doesn't even make sense, the average transactions by date. There's only one store, so we're good. Instead, and we're ordering by the date. So we got 2nd, 3rd, 4th. Okay. So now let's change this a little bit. First of all, let's partition by the, instead of partition by date, we'll partition by the store number. Okay. So what does that mean? This is going to be the average across each store. In this case, there's just one. So it'll be the average of all these transactions. So this number is the same. Now, this is going to change once we add an order by, if we add an order by to the window function, meaning inside the parentheses. So now we'll do order by, let's say we order by the date, okay? And we order by the date ascending. Let's see how this changes things. So what this does, this all of a sudden changes our calculation to being a running average, okay? So this is why, for the first day, it's like, what's the average number of sales? Well, 2,111, because we've only seen one day so far. Now, in this case, we've seen 2 days. So this is going to be the average, 2,111 and 1833. Plus 1833, right, it's 3,944, right, divided by 2. That gives me 1972. Which is what we got here. Okay, so this is the average of these 2 days. Now this is obviously, right, the average of these 3 days. So this is giving us the running average. Once you put in an order by, it's going to be the running total. You could do the same thing with like sum, right? Like this will now be the running sum. of all the transactions. So if we want to like hit a specific number in a week or something like that, maybe we want to calculate the running total. So this value here is obviously just the two preceding added up. Notice that again, like this only affects this order by only affects this one individual column. Okay, so in other words, we can change this. We can order by the number of transactions, or maybe this will be a little confusing, but this will show me, and it won't affect. So now this data is, but notice this now. This is not always increasing. Why? Because it's showing me the running. This is the running total. Let me change this name. This is the running total since Jan 2013. If I can do that. All right. So this is 2016, and this is how many items we sold since January 2013. Right? This column is still performing the same calculation. We are grouping by the store number, ordering by date, meaning once we do order by, that means we're moving into a running total, and we're summing up the transactions. Okay, so you kind of have to just think of this. This whole window function is only affecting the one specific column. Right? Once you, if we take out the where store number 1, just remember like this partition by means what? It means we start over with each store number, right? So this is showing me everything about 1, but once we go to store number 2, now our running total starts over, and it's going to begin with that same day of January 2013. So I wonder, here you can see this, right? Here's 44, right? And let's actually order by date. It'll be easier to comprehend for now. Okay, so here you can see, can we start to see this? We'll do order by store number, comma date. This will be better. Okay, so this is all about store number 1. Here's the running total, right? It keeps getting bigger day after day. Then we go to store number 54 eventually, and now this is also going to be like a running total. Just keep getting, here it only gets bigger by 903, right? Here it gets bigger by 1,000, 8,000, 6 to 9,006. Okay. So what's the point I'm trying to make here? So once you do the order by, you're going to move to a running calculation, but that's order by inside the window function. There can always be a separate order by outside the window function, and this is the order of the data set. Okay? This in here is the order of the calculation affecting just this column. Right? The running, what it means to be like running. Yeah, Sina.
So before you put in the order by, you were partitioning by the store number, it was like taking the average, well now the sum of transactions for like all the stores.
The entire group, yeah.
And so the entire group. And when you add the order by, now it seems like it's really just looking at per store.
Well, in each case, it's per store. So let's think about this. If I take this out, partition by the store number, now let's see what happens. This guy just has the same, this is the total of transactions of store number 1. So it's constant, right, across all the days. Because this column just calculates what's the number of transactions store 1 ever did, right? Add up all the values. Now this is the number of transactions 54 ever did. So it's constant, across each store. Once I do the order by, it moves to a different value for each store because it's a running total. Every day they get more transactions. So I order by date. Once you do order by date, we'll start here at 2,111, I'm guessing. And then we add this to the running total. And then we add this to the running total, etc. Right? So, but this value, this number 54, right, this starts over. Like once we get to, here at store number 1, but once we get to store number 2, we're going to start back over at its first day, if it was 2013 or something like that. Let's see if we can do that where... from store transactions where store number, let's say in 1, 2. So basically show me either stores 1 or 2. Yeah, and here's the running total. And it's not the best because, we're seeing limit. Let's do like limit 2000. Maybe that'll be better. 18. Yeah, so here you can, it doesn't help because these numbers are just so big. But ideally, what you can imagine happening is, and I think that this is where the graphs are particularly useful. You can see it here. Here what we're doing is I'm partitioning by the date. So every day we start over. That's what you want to think about it as. Every day we start over. Ordering by the number of transactions. So I'm saying, all right, give me the day that had the largest number of transactions, followed by the second largest number, right? Followed by the third largest number. So as my running total. So we're partitioning by the date. So this is all the same day. This is my top performing store for that day. Now here's my second best store for that day. And you can kind of like see that we get there we go through all the stores for that one day. And then once we get to the second day, we start over, right? Because we're partitioning by the date. Okay, my grouping of this running total is just across one day, and then we start over on day 2 and start over again on day 3. Okay, if we partition by the store number, order by the transactions. Now for a given store, what am I going to see? I'm going to see the top day, right, for a store, and then once I get to store 2, start over. So let's see. This is going to be harder probably. Yeah, see that? It just keeps going up because we just have a large data set. But I wonder, let's not take away the limit. Let's do limit like 5,000. Yeah, you see this? So this is, store number 1, probably, across all the days. Then once we're done with store number, that's why there's 1675 records. Then once we finish with all the days, now we start over with store number 2. Now, store number 3 seems like did very, very well, right? Or maybe it just has more days. It looks like a steeper slope. But this is, this is interesting. Like this is like for those of you who have like maybe worked in like business before or something like that. Like knowing like the most important days of the year that something sells. Well, like we should probably pay attention on those days, right? So yeah, so once you put in the order by, this turns into a running calculation. So that's kind of like point number 1. Point number 2 is this is still only affecting this one column. You can change the order. You can say like order by whatever you want, and that changes the orders of the rows, but keeps this calculation per row the same. There's a lab that really emphasizes that, so I think it'll become clear there. All right. Yeah. The other thing you can do, which you'll get a reading on, you can sum the transactions. Like that's one calculation. You can also just give yourself like a rank. So I can use the same thing instead of the running total. I'll say let's calculate. So for each store number, show me the top ranked day. Okay, let's call this top ranked day per store from transactions limit 1. I broke it. Let's see why. So it says near limit, order by something, right? There's no answer here. Order by what? That's just fine. We'll say order by store number, I suppose. So this is store number. This is the top ranked day. So let's do store number, comma, transactions. Descending. Okay, so yeah, we're kind of, I don't know why, I would think this would start at 1, but it's okay. So you can see this is day rank number like 2 for this store, like order by transactions descending. So this is, I guess the second best day that it did. I don't know why it's not giving me number 1, but then there's 3. But what you could do, which is kind of cool, is you can see like what day did each store do the best. So order by store number transactions. Let's say like where top ranked day per store equals. Let's see if we can do 1. Is there anything here? Maybe I can't do it. It might have to be having.
I think it's because you're slicing the data frame.
It's breaking here. Like it's breaking before I get to that. Let's take out the, I think it might be this. Let's take this out first. Okay, it doesn't like this equals. Where, so let's say where. How do we do? Misuse alias window function, so that's pretty specific. I may have to do, I wonder if it will let me do having. Otherwise I have to do it as a subquery. Nah, I can't reference it. That's a bummer. Can I do this? Order by top ranked day per score. Ascending. Yeah, that's kind of cool. So for each store number, I'm showing their top ranked day per store. All right. So this guy's store number 2 everybody did the best on Christmas Eve. What a surprise! But this guy seems like did the best the day before. So we could see what's going on there. They have a particularly, planning, well thoughtful parents. All right, it's store number 8. But anyway, these are kind of interesting queries to do. All right. So this thing rank, right? This is calculating the rank, the number, just like 1, 2, 3, 4, 5. There's different ones of these. There's also like dense rank. There's row number. I'll let you all look them up. There's slight differences, but also the lab goes through them. All right. Do you want me to focus on something else? Any questions before I put you into breakout rooms? No? All right. Let's do it. Okay, so here, let's do this. So let's get an overview of how the movies performed. Rank the top earning years for each genre and order the entire data set by top earning years per genre. So all right, first thing, we just have to understand the question, make sure we get it down. Top earning years for each genre. Okay, so for me, if I'm basically trying to see the question is again each genre per year. And just know that we start off with a list of movies. And now what we're curious about is how much each genre earned per year. So each row, you then want to think, okay, what's this resulting row? And it's it's genre comma year, right? It's for each year, list all the genres and then calculate the income. All right. So we're reducing the dimensions, right? We're going from a bunch of movies to now a bunch of genres per year. And when you do that, that tells you it's group by. All right. So the point is, the first thing to get a handle on, the first thing to solve in these queries is just what is the dimension of the data that we're aiming for? And in this case, you can see it here, right? It's a different, for each year, different genre, and therefore different calculated income. So let's do that. So it's select all from movies, group by genre, comma, year. And I would just select, the genre, year, and then let's say the sum of the income as total income, right? We can only really display what we're grouping by as the columns and also any aggregates relevant. Let's just do limit 10. So do this from the movies, group by genre, year, limit 10. All right. Now we have this total income is none. I would just like clear, this is probably, right, null values. I would say like where income, and this where clause has to go before the group by. Where income is not null. So get rid of my null values and then group the remaining. So now I have total incomes per genre, per year. I think that's, like, I just want to check the dimensionality. Again, like I would reread the question at this point. Rank the top earnings years for each genre and order the entire data set by top, order the entire data set by top earning genres per year. So that means I can now do this order by. Order by, well, the top earning genres per year, I want to order by by top earning, right? By the total income. So order by total income, descending. Right, this is, all of this is like things we have seen, like a month ago. Right, group buys, order by, right? There's nothing, but that's kind of the point, is just get this stuff down first. And now the next thing is rank top earning years for each genre. So I want to, so one thing, just, so this is where the window functions are going to come in. Just to like emphasize the difference between like a window function and group by. With group by, we're really doing a different, like, and by that I mean like unrelated, essentially, calculation for each grouping. This is how much action adventure sci-fi earned in 2018, right? There's the total income. We got the same, this is a very popular genre, but this calculation is unrelated. Like, this guy can go up as much as it wants. It's not going to affect this value of 2015, right, to SQL. We can go down here, right? Again, this value can go up or down or whatever. It's not going to affect any of these other values. With window functions, that's not true, okay? With window functions, the fact that this guy is number 1 is influencing that this will be number 2, right? So I like to do the window functions last because you can see it. Window functions are calculations like down through the data set. Like you can 1, 2, 3, right? Ranking per the genre. Here's, here we have these comedy things, 1, 2, 3. So window functions operate like down through your resulting data, whereas the group bys are like unrelated to one another. They're these separate piles that we have aggregated. All right, so we've piled up all of our action movies in 2018 and added them. Piled up all these and added them. Then with the window functions, now that we've done that, we compare the resulting rows. All right, so let's go to it. So we need another column, essentially. We'll do rank over. I just always remember I need that word to make it a window function. And then I want to partition. And then what's the groupings? Like, what are like the related groups? I think it's the partition by genre, right? Because I want to start over with each genre. And then order by the total income, I'm guessing. I'm not sure if we can reference this, but maybe we can. We should be able to. I can't do it. I lied. Partition by genre, order by total income. So maybe I have to do sum of income. Man, that's a bummer. I wonder if that's the road to glory. I don't know. As ranking total, it can't be. Oh, maybe it is. If this is a descending. Yeah. Okay. I guess I could do that. Right, because this is one. Like I can check the result. Right. This is my total income for 2018, and among, genre years, whatever. This is the top ranking, like this is the best that any genre has done that we have data on. This is the second best that any genre has done, right? And then this is the third best but this is the best of this genre. This is the best of this genre, I should be saying. And now we finally have a new genre, right? And because of that, we're starting over at 1. Right, so I can really check the results here with my window functions in a way that's it's like hidden, right, with the group bys. So again, like what was the point here? 1, get down the dimensionality first, right? Where it's rank the top earning years for each genre. Let's get it. Like this is kind of blind because I say movies perform, but really it's okay. For each genre, what are the top earning years? To do that, we need to add up, right? And this is, we want 1 row for each genre, comma, year. So once you get that down, then the window functions are almost visual, you know? You can see that, okay, across the genres, for each genre, we can see the ranking of that year. And that's, and that's where the window functions come in. It's the same thing if we were to say, add up. Let's say we want to see like, the total or like the running total of the income per year. Well, I guess it's not useful here. We could say the running total of the income per genre, though, right? And that, again, that would be visual. We'd be adding up this income and this income, right, to get that running total. Let's just do that. So this will be the sum. Oh man, I don't know if I can do it because it's really going to be a sum of a sum of the total income. It seems like that's going to be hard. I'm going to hold off on it, but that's what it would, when we get to subqueries, it'll be easier. But if I did a window function of it, right, you can see that we would be adding up, we would be, again, going down across these rows, these resulting rows, right? This would be this plus this, and then it would keep going. All right, so that's the point. Get down the dimensions first, then from there you can start to see the window function. It's just adding another column, right? But I'm getting all the ordering, get my data set down, and then this column really operates like independently, and lots of times you can even kind of calculate, like check the answer just with logic, right? That this guy is top ranked in this genre, followed by this one is second ranked, and now we have a new genre here. Okay. All right, questions with this? I mean, overall, I'm advocating the same procedure as find a way to take these SQL queries in stages and check your work along the way, right? That's the approach, always. All right, I'll let you all keep going. I know that you're still working on like the sliding window functions, things like that.